So we are going to study molecular vibration of water molecules. A molecular vibration occurs when atoms in a molecule are in periodic motions, while the molecule as a whole has a constant translational and rotational motion. The frequency of the periodic motion is known as the vibrational frequency, and the frequencies of molecular vibration range from less than 10 power 3 to 10 power 14 hertz. So this corresponding hertz value will be equal to the number of 300 to 3000 per centimeter. So the molecular motions I already told it include the motion of translation, rotation and vibration. So the total number of degrees of freedoms is equal to 3n, where n is the number of atoms in the molecules. So 3n type of motions has the 3 represents molecular translational in x, y or z directions. Linear molecules have 2 rotational degrees of freedom and non-linear molecules have 3 rotational degrees of freedom. For linear molecule, the number of molecular vibration is 3n minus 3 minus 2. So totally 3n minus 5. Non-linear molecules have the number of molecular vibration 3n minus 6. For linear molecule having the molecular vibration of 3n minus 5 and the non-linear molecule have 3n minus 6. So to obtain the reducible representation for all molecular motion, we must consider the symmetry properties of the 3 Cartesian coordinates on all atoms of the molecules. The molecules lies in the xy plane. The x-axis is drawn in blue and the y-axis is drawn in black and the red arrows indicate the z-axis. So if a symmetry operation changes the position of an atom, all 3 Cartesian coordinates contribute to the value of 0. For operation that leaves an atom in A, the character is 1 means for an axis that remains in position. So 1 means remains in position, minus 1 for an axis that is reversed. Minus 1 for an axis is reversed and 0 for an axis that has been moved. So to identify the reducible representation for the C3b point group symmetry element, that is E, C2 and sigma V XZ and sigma V prime YZ. Okay, first we are very well know the identity leaves all 3 atoms in water molecule. It does not change the position. So there will be a character of 9 for identity operation. So the next we have to perform C2 axis rotations through oxygen molecule in Z axis. So the C2 axis goes through the oxygen atom and exchanges the hydrogen atom. So the Z axis, that is red in color, and oxygen stays in position. This axis contributes +1 towards the character for C2. Y-axis and oxygen is rotated by 180 degree. So this reversed axis. So it contributes a value of -1 due to the character of C2. So as the x-axis and axis is rotated about 180 degree, this reverses the axis and contributes to -1 to the character for the C2 axis. So finally, the reducible representation for the C2 axis is that is -1. So the character of C2 operation will be +1, okay, in Z axis and -1 for y axis and -1 for x axis. Totally, the reducible representation for the Z axis in water molecule is -1. So next we will move on to that is sigma V XZ axis. So the XZ mirror plane is the molecular plane. Okay, XZ mirror plane is the molecular plane, and all the 3 atoms remains in position. So the positions are not changed. So the Z axis and the x axis both lie within the XZ plane. Okay, the both Z and x axis plays on the same plane. So this remain unchanged. So each unchanged axis contributes to +1. So the character for the symmetry operation is +1. So for 3 atoms, the contribution to the character will be 3 into +1 is equal to 6. So the y-axis will be the reversed by the mirror plane. So x is Z. So the value, it contributing the value of -1 for each of the 3 atoms on the plane. So the character for the XZ mirror plane will be 6 minus 3 is equal to 3. Okay, next we move on to sigma v prime yz or sigma v yz. So yz mirror plane bisects the molecule, only the oxygen atoms lies in the plane. So the y and z axis within yz plane, so both of them contribute to +1 value. So the x-axis and the oxygen is reversed by the reflection and contribute the -1 value towards the character of sigma v yz. So the character for reflection in yz plane is +1, +1 and a -1. So totally we got 1 for sigma v yz plane. So by using the above reducible representation, we have to calculate the molecular vibration of, that is, water molecules. So the above reducible representation is also called as, that is, reducible 3n. Because 3n modes is also designated as a molecular motion. It combines or include the translational, vibration and the rotation, etc. So the 3n modes of vibration of water molecule is having, that is, 9 modes. Okay, so 3 of A1 and 1 of A2 and 3 of B1 and 2 of B2. We are already known that what is A and what is B. A and B designate the one dimensional way of symmetry, and the subscript 1 and 2 is the one is the, that is, symmetric nature by performing the operation of, that is, C2, and 2 is the antisymmetric nature by performing the operation of principal rotations in C2 axis. Okay. Then next, 3n reducible representation for a water molecule is the 9 modes, that is 3A1 plus 1A2 plus 3B1 and 2B2. So there are 9 modes of motion. These includes, we are very well known, vibration, rotation, translation. So among these 9 modes, particularly we have to pick out the vibration of that water molecule. How do we pick out? So we have to pick out the particular vibration of water molecules. From this 9 modes means you have to know the value of translational and the rotational motion by using the periodic, that is, character table. So by using character table, this is the C2V point group character table. We are very well known. This is the Millikan symbol for the C2V point group. This is the character for that C2V point group. This is the symmetry element, that is adder of the group. We are already known that these two columns indicate the some basis functions. So this columns indicate the rotational, translational motions of the particular molecule based on chemistry orientation of orbital in X, Y, and Z. Okay, so by using this column, we have to identify the translational and the rotational motion. So the translation motion is mentioned in the character table as X, Y, and Z. The rotational motion is also mentioned by Rx, Ry, and Rz. Okay, so first we have to find out the translational motion of water molecules using the point group, that is character table of C2P. So the translation have the same symmetry properties as X, Y, and Z. Okay. So next, so we have to find out and we have to check the character table in which place the Z axis is lie and X axis is lie, Y axis is lie. First we have seen that Z axis is lie in the place of A1. Okay, A1. So the translation among the 9 vibrational modes, 1 vibrational modes of A1 will be reduced to, so the among 3A1, 2A1 is present. Next, we have seen the X in B1 mode. So B1 modes also reduced from 3 to 2. Okay. Next, Y is present in B2 mode. So among the 9 vibrational mode, that is 2B2 is reduced to B2. So totally we have got 2A1 and 1A2 plus 2B1 and 1B2 for translational motion for water molecules. Next, we have to find out that rotational plus translational mode. So rotation have the same symmetry as Rx, Ry, and Rz. So rotational vibrations will be occur in A2 mode. So we have to reduce the 1A2 into 0. The next we have Ry, because this will be reduced to 1, and 1B2 is also reduced to 0. So totally we got, that is, 2, that is 1, 2A1 plus 1B1 and so finally we got the total number of rotation and vibrational motion for the water molecule is 2A1 plus 1B1. So there are 3 vibrational degrees of freedom. So we have to check it that is we have already known that the non-linear molecule having that is 3n minus 6 normal modes of vibrations and linear molecule having 3n minus 5 normal modes of vibrations. So here we have water molecules 3 atoms. The number of atoms will be 3. So we have to put the value of 3n minus 6. The n value is equal to 3. So 3 into 3, 9. So 9 minus 6 is equal to 3. So we have to find out 3 normal modes of vibration for the water molecules. Here also we have to find out that 2E1 plus 1B1. So totally we have 3 normal modes of vibrations. So they are the rotation and the translation motions of water molecule is, that is translation motion is z axis and the translation motion in y axis and the translation motion in x axis. So here is the rotational motion in EZ, rotational motion in x axis and the rotational motion in y axis. So molecular vibration is totally the number of vibrational motion is 2A1 plus 1B1. So 3 vibrational modes remains, 2 have A1 symmetry and 1 has B1 symmetry. Okay, 2A1 has the same symmetry and 1B1 has antisymmetric in nature. So 2 vibrations are symmetric with respect to all the symmetry operations of the group. 1 vibration is asymmetric with respect to rotations and reflections perpendicular to the molecular plane. So the totally A1 has the 2 types of modes, that is one is symmetric stretching and another one is bending vibrations, and next one is B1 is asymmetric stretching vibrations. This frequency range is observed in 3652 per centimeter for A1 symmetric stretching and 1595 per centimeter for A1 bending vibration and 3756 per centimeter for B1 asymmetric stretching vibration. Thank you.